Hello, I'm Li and this video is about the final project the current progress of the final project I currently done in computer architecture course. So this topic is about the integration of the software renderers into my CPU and accelerate. So the integrated software renderer in this project is B3D. So B3D is a minimal software 3D render in the C99, and it supports the triangle rasterization with the depth buffer and the clipping, and also the perspective projections with configurable FOV. And also you can do some model translations and also some camera controls with it. And also important, this project is also supports the 16-bit depth buffer to lower down the memory footprint if you want during your current uh, object rendering. So some interesting point in this project is it supports the use of the Q15.16 fixed point arithmetics without the use of the floating point arithmetics like the floating point multiplication, floating point division, and this kind of like using the fixed point arithmetics in the default, since they considered some CPUs that some CPUs or some processors that doesn't contain the extensions of the floating point arithmetics or such as these these CPU architectures in RISC-V that only uses the RV32I instruction sets, and which is what my CPU, this CPU architecture, is in. Yeah. So this project will uh, make the fixed point arithmetics a default. Yeah, is to serve on uh, the problems or the cases that I just mentioned before. And okay, so let's dive into the report is the node itself. So during the start of the weeks while uh, implementing this project, I first learned the chisels, which is the which is a library, which is a chip library that which is a chip library in Scala language that uh, the project my CPU does. This the project my CPU implemented its chip into. So I learned Chisel, and I learned the Chisel through the Chisel bootmap while installed it locally. And after going through some exercises in the Chisel bootmap, I spent some time to be familiar with the my CPU project since the software renderer, the integrated software renderer is need to be targeted to the my CPU, this CPU processor. And this CPU processor is just like I mentioned before, it is it is created or implemented with uh, the RISC-V the RISC-V architecture, and it only contains the RV32I instruction sets with the considerations of the what is it called? Oh, the extensions for the control and status register instructions for the CSR usages. And yeah, I I've been familiar with the my CPU with doing the exercises listed in this project. And okay, let's just dive into the project itself and see what I've done in the currently or in recent week or the recent weeks. So B3D. B3D is a minimal software 3D render in C99, just as I just mentioned in the previous words. And in in this project, just typing the make all and in the B3D render library, then it will compile the source codes. All of the source codes in the library, such as the examples and the also the source the source code and the test codes. And for the examples, you can see the compiled examples in like the top level of the directories of the project directories itself. So if you want to just run a uh, if you just want to run a simple programs, for the examples, you can just, let me see, you can just, after the compilation, just execute one of the programs, such as cubes. Then you can see you can see the rendered effect of a, in this case, is a cube, yeah, or model of cubes in here. Okay, so yeah, this is the project itself, and also it has a program which is called objdc, and this example program is showing a example of how how the B3D renderer, yeah, how the B3D renderer can parsing or processing the object files, which is tailed with .obj in the assets directories. Uh, yeah, it's just that how it could process the object file or scans the object file, and also with the use of the B3D object in H to processing those object files, and to and later it will render the 3D models based on the object file information that it parses with the help of the B3D obj, with the b3d-obj.h, and to render a simple render some simple 3D models is that is requested or that is switched from the user's input. So yeah, so this GIF in uh, this GIF in this hackmd notes is the uh, is how it is execute. Yeah, is how it is execute, like when you type in the slash obj, then it will start with the cube, which is from the top of the assets, and later it will like switches to the X%, equals equal whatever it calls. Yeah, so it will switch with the objects with the user input to when the inputs to left or inputs right with the keyboard. Yeah, and it will switches the object that shows in this uh what is it called? Oh, in the screen, in the little screen itself. Yeah, and what what the file is called, what this kind of files like the files that is tailed with the obj is, it has a name which is called the waveform the obj files. And for this, for some goals of this project is, one of the goals of this project is to develop a building workflow to convert the B3D graphical assets. So in my cases, or in my script cases, I only done the building workflow of the uh, I only done the building workflow of the convert the B3D graphical assets is to convert its convert its object file assets. That is object file that is tailed with that is the file that tells with .obj, and yeah, the .obj, and only process those files or processing those files into a header file, which is called b3d assets.h, and this is a file that only contains the parsing or the result of the object. Yeah, the result of the parsed object file elements or parsed object file information, and I just expanded the information listed in the object file into a C by array format and make it saved in the section which is called the assets, while this header file is linked with another C programs that are used that will use the link.lds linkers, the link.lds linker script. Yeah. So in this linker script, you could saw a source of code that represents the asset sections in this while while uh, while I want to not this while I want to link b3d assets.h to other programs such as the let me find such as test linker.c, which is a program that I used to check if the linker script works well while I to check if the script works well this while this program could actually read the read the cube assets here could actually read the cube assets and the b3d assets.h uh, from including the b3d assets.h header file and to to check if this these data uh, could be read properly during the program and stuff. So yeah, so back in the project note. Okay, so back in the project note. So for the first of the project, while implementing the project, is I first do the object file format and the CBI settings of it. So what is a waveform object.obj file format? So it is a open file format that typically accepted by most of the renderers, by most of the software renderers. Yeah, and generally it contains the following elements. So first of all is the V, is the element V. So it represents a geometric vertex, defines a point of the 3D spaces, of a point in the 3D space, which is X, Y, Z. And another, sorry, and another about another elements that you might see in object in the waveform object file is the text vertex, which is head with VT, and it defines the point of the 2D texture maps, which is this. And there's another element that you might face is the vertex normal VN, and it defines the direction of the surface that it is facing. Uh, and the final one is the symbol F, and it defines a polygon, which usually is a triangle or a quad, by connecting the indices of the data points listed above. So it would typically just be like this. This is an example of I took from the object file in here in B3D assets. Yeah, this is the example of the pyramid B3D assets in this example. Yeah, from the pyramid object file. So as you can see that typically the object file, sorry, typically the wavefront object file uh, will contain the vertices, and sometimes it will contain this texture coordinates or the normals. But generally, most of the or all of the waveform object file will actually contain the vertices and the faces only. Uh, in this example, that you can take the cube object as an example that it only has a in this object file, it only contains two kinds of elements, which is vertex elements and the face elements. Yeah, the face elements. So not every object file will determine how the texture coordinates or the normals of this 3D model or this 3D object will be determined as. Yeah, and and so okay, so we get this file. Then how could we use this file to make the render to render a 3D model based on these informations. So there's a uh, there's a technique which is called fin triangulation. Why it is called fin triangulation? Since uh, most of the renders will process the polygons, or yeah, process the polygons with the decompose them into multiple sets of the triangles. So why they will process them in triangle is because the triangle uh, is the simplest polygons in yeah, it's the simplest polygon with only 3 points and the 3 edges. And yeah, and so for this so for this example, so we just take this as an example of how the render will take will, will process this object file into a multiple set of triangles. So this example is a five-sided polygon, uh, which will build a pentagon in default. So according to the definition of the face elements, which is this f, which starts with the symbol f, and it will last with 1, 2, 3, 4, 5, and the pentagon or this five-sided polygon will be decomposed into the following triangles. So for this case, that it will decompose into three triangles, which is triangle one, which will connect the anchor one to the first pair, which is two or three, and the triangle two, which will connect the anchor to the second pair, which is 1, 3, 4, and the last triangle will connect the anchor to the third pair, which is 1, 4, and 5. Yeah, so this kind of the expansion or kind of the decomposition is called the Venn triangulation. Yeah, and the process of the Venn triangulation is to split the polygons by choosing one vertex. One vertex. Typically it is the first vertex. The first vertex in the element line, that starts with the symbol F, and drawing lines to every other vertex on the rim, which is on the rim is like 1, 2, 3, 1, 3, 4, and 1, 4, 5. Yeah. So based on this processing, then the result of the Venn triangulation of this object file will be like the following cases. So what 1, 3, 4 means is uh, 1, 2, 3, or 1, 3, 4, and 1, 4, 5 is in here that we have a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 vertices, and each of the number in the face elements represents the number of the vertex in the vertices element list. So to pair the triangle 1, 2, and 3, uh, in this case we'll make it be like the vertex 1 combines with the vertex 2 and the vertex 3, so it would be drawn like this. Yeah, so it would generate a triangle sets like this. And the triangle 2, on the other hand, since it's connected the anchor 1 to the second pair, 3 and 4, so it will generate a triangle sets like 0, 0, 1.0, 0.0, and the third vertex, which is 0.6, minus 0.8, and 0.0. And the last will be minus 0.6, minus 0.8, and 0.0, which is this. And the triangle 3 will be act as same as the previous triangles do. So it will take the vertex 1, vertex 4, and vertex 5 of the vertices list. So it will generate a triangle sets, the big triangle sets with this kind of form. And additionally, so the object file consumptions, um, I believe uh, it's in this, yeah, p3dobj.h. It only parses the no, no, obj. Yes, so in this code, so it is p3dobj. H header file. It only parses the vertex and the faces, and ignoring the flags such as the VT, the texture coordinates, and the VN, the normals. So uh, and since this renderer won't read these two coordinates, which means that the if we consider the faces elements with this kind of forms, VBTVN, this kind of forms, that the parser, the parser of the object file will uh, automatically ignores the second and the third element, which doesn't represent the vertices list of what the fan triangulation the fan triangulation process does. And yeah, so it will just ignore these two elements and only takes the first element in order to do the fan triangulation. So yeah, so just what I write in here, it will discard VTVN and just only read the V element V element value in this form. So in the building scripts of the assets file, I wrote it in uh, gen assets data.py, and yeah, running the array collect. Oh yeah, here parsing the obj file. So yeah, so I just done the similar work with what obj v3d obj.h does, and just only read the vertices, uh, or to save the or to buffer up the vertices in this current object file, and also reads the first element, the first value of each element in face in the face flags. Yeah, ignoring what is right of the slash, and later to perform the fan triangulation based on the vertices list and the rules in the face elements. Yeah, so and later it will automatically print out the results with hexadecimal numbers into a C header file, which is called b2dss.h that I just mentioned before. Okay, so B, okay, so b2dss.h, and yeah, just as I said before, that after the waveform object file that is parsed and processed by the building scripts gen_ss.py, and it will output a file which is called b3dss.h. That will save the waveform object file into the cbyte arrays. So the cbyte array format in this header file will be served like will look like the following C structure definition, which is starts with a triangle count and a vertex count, and lasts with the triangle vertices. Yeah, the triangle vertices. Nine, which will be nine vertices for a triangle set. Yeah. So this kind of format is what does it implement in here? No. Yeah. So this kind of format is the format that or here. Yeah, here. It is the format that the object file, the B3D object file, often saves the parsed or processed access information from the wavefront object file. And yeah, so based on this structure, I make the cbyte array format to be like the first number of it. The first 32-bit number of it will be the triangle count of the of this current uh, array object. Yeah, and the second 32-bit of this array will be the vertex count of it, and the following the rest of the following array elements will be the triangle sets of this object after performing a fan triangulation. Yeah. So Oh, and also the elements of these fan tri the fan triangulated sets are all being encoded into the Q15.16 fixed point and not in the floating point since my CPU doesn't support the floating point arithmetic. So we need to consider this and to make the use of the Q15.16 fixed point arithmetics to be the default. Yeah, so I decided to pre-encoded these floating point or theoretically would be the floating point number into the fixed point number. Yeah, before that these data were read by the read by the renders that will be run in that would be built or execute uh, with the my CPU structure with the my CPU four socket structure. Yeah, or four socket architecture. Sorry. Yeah, and this just lists that the code that I added in the linker list, linker script. So the code that I added in the linker script is here. Yeah, and yeah, in here they also write that I write testing linkers, the testing linker program to ensure that the data, uh, ensure that the data that is saved in the asset section while the program, the B3D assets.h program, is linked into other C program with the use of the modified linker script. Yeah, so after the compilation of the test linker, then you will get a test linker.asm, and by typing the make comment in the make file, yeah, by typing the make test linker.asm with make file in the forsock C source C source uh, directory. Yeah. After you're typing this, then it will generate a test linker.asm, the ELF file, and yeah, ASM file, and also it will generate the DLF file for it. So if you want to check or how I check if the linker script is uh, manually successful is I check the yeah is I check the comment with obj dump with the test linker dot elf after it's compiled into the uh, for sock C source, yeah, C source. After the programs, after the testing programs is linked with the B3D assets.h. So yeah, so after the compilation that you will see there contains the ELF file. It will list in here. So it will contain it. Oh yeah, it shows in here. So it will contain the testing profiles of it. So after you typing on this, then it will show that oh, it actually could read the contents of the contents of data the asset section in this yeah in the asset section in the assets sections after the B3D assets.h program is linked with this test linker.c programs. Okay, yeah. So this is the way I check if the linker works well after I uh manually uh, manually changed it. Okay, so for next of it is the VJ validation program, the simple render. So the simple render for the VJ validation program is in these two comments. Yeah, the information you can see in these two comments. So, but unfortunately, is that these two programs currently cannot render the objects of yeah currently cannot render the object and animate and also animated properly. Well, if we straightforward to the result, it will just serve as the following GIF that I use the make check VGA I use the make check VGA make file comment to try to execute it, and it shows that it just only print out a single surface of the cube and doesn't rotate it. And I'm not sure that if this cube is uh actually being rendered straightforward by this render. Yeah, so this need requires some of the checks for it in the future. Yeah. Uh, so for this work, okay. So back to the section. Back to the start of the section. So uh, how does the simple render with the VJ validation program I make is I derived most of the functionality of the render from the B3D library. Yeah, I derived most of the functionality from the B3D library to create a simple render, which I named it as S3D which I named it as S3D uh, to be simple render the simple render library for the use of the VGA validation pro to the use of the VGA validation programs. Okay, and yeah, so why I choose to derive most of the functionality from the B3D library is because of I'm not quite familiar to what computer graphics does. Yeah, I'm new to this kind of the subject or this kind of the category. I so while implementing this kind of project, uh, I spent most of the I spent some times or much or many of the times on how this on what is a 3D what is a 3D rendering or what is a 3D render and also what is a computer graphics or some nouns or some professional nouns that listen to computer graphics means, such as what is rasterization, yeah, what is rasterization means, and some other stuff like what the buffer serves as. Okay, so yeah, so I spent some time for learning the 3D rendering or learning the computer graphics through the open courses in the online in the YouTube, and also read some of the open materials uh, that is in the triple W. Yeah. So I took some, yeah, so the following notes including the start of the 3D rendering of the triangles is what is the, yeah, this is kind of a learning notes. The learning notes I learned, the learning notes I record from, that I record from the progress of the learnings while I was learning the graphics, sorry, learning the computer graphics to uh, the MIT course 6.837, the introduction to computer graphics. Yeah, yeah. So these are some of the learning notes, and the learning notes and the yeah the the relative implementations that is relative to these techniques in the S3D. Yeah, these are kind of some of the notes that like that. So I just skip them normally and jump into the some problems that occurred when I tried to make the VJ validation program works. So okay, so as I said before, in the previous words, is I mostly derived the simple renders from the V3D library to implementing a simple renders for the VJ validation programs. The another reason why I choose to took the functionality from the V3D is the integration. The topic of this project is to integrate the software render into my CPU, and just and the, just took the functionality of the B3D could be a pioneer to serve as like a pioneers to check if there will have some problems that in the future integrations while I want to do the future integrations for the B3D into my CPU processor uh, to check if there is any sorry to check if there is any problem while doing uh, such integration works. Yeah, and this is some of the problems that while I tried to like making the simple renderer, which is named as S3D, uh, to be used with the VGA validation programs. So the uh, the general reasons that the I occurred in the error is the use of the multiplication, the multiply, the division, the modulo operands, or yeah, oh no, 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 no. It's mostly because of the use of the multiply, division, and the modulo operators that basically were all being used in the original B3D programs. Like although I mentioned in the start of this video is that the B3D supports the use of the fixed point of the arithmetics for making you have a chance to not use the floating point arithmetics. But in reality, some of the calculations B in B3D still uses the floating point arithmetics. So uh, take this actually take the take the auto-generated header file or the file that is last with the ILC, which which is called this mathgen.ilc. This is the header file or the ILC file that is auto-generated from a little script which is called math.dsl, and this is math. And it supports the math operations, the pure math operations of the vector operations and the matrix operations, and only with the floating point mode. So if I want to uh, derive the matrix or vector operations from these programs into the version that could be supported by my CPU, which I typically wrote them in math.h. Yeah. If I want to do this, then I have to change out of the codes, yeah, to transfer all of the math calculations or the arithmetic rules and to stick them into the floating not floating point to stick them into the use of the fixed point, which I just transfer like the the floating point multiplications into the fixed point multiplications and uh yeah, and replacing the and also the division, yeah, and replacing the floating point divisions into the replacing the floating point divisions into the fixed point division. Yeah, so yeah, just do this kind of the transformations and yeah, the problem with the matrix and the vector operations is just transferring the floating point arithmetics into the fixed point arithmetics, and despite of that, despite of that, the another the another problem with these codes is since my CPU doesn't theoretically it doesn't accept the M extensions in its program. So theoretically that it couldn't configure the specific symbols such as the division symbols or the multiplication symbols while you compile the code. Yeah, while you compile the code or to link the code into uh, integrate them into the object files, then you will occur some problems is that then you are faced with the problem of that the compiler or the linker or the CPU couldn't, yeah, or the linker couldn't recognize this kind of symbols, such as the division symbols, the multiplication symbols, and yeah, and sometimes there's not sometimes, and there's the modular program, a modular operation in the original B3D, uh, in the original B3D programs. So in this error message, you'll also see the MOD symbols in here. Yeah, so I've spent some time to transfer the codes that containing the illegal operators into only shift and add calculations as possible. Yeah, so the below changes is some highlighted changes I have done to the math operations in the original B3D to make it to be suitable for the fixed point arithmetics or to make it to not to not rely on the use of the multiply or the division and or the modulo operators. Yeah. So the first of these highlighted changes is not using the multiplications at the at the macro s3d int to fp. So this macro is to transfer the integer into the fixed point number. So it originally method in the B3D that it will use the multiplications, yeah, to avoid the upper bit with the negative values. Yeah, so but in the MyCPU case is that it does not support the multiplications. So this kind of concepts will uh, make it to be a illegal operators in here. So I change it back to use only the shift operations by making the input integer number first assigned it as a unsigned bit and to perform the shift and later to assign back to S3D fixed t. S3D fixed t data type is defined as the defined as int32t. Yeah, in these cases, which could be seen in here, which could be seen here. Yeah, S3D fixed t is typically or is in here is defined as the int32t. Yeah, integer 32 bit. Signed integer 32 bit. Okay, so the next highlighted changes is I changed the logic of the fixed point multiplication. So the original fixed point multiplication is it will just rely on the use of the multiply operand and also the 64-bit number to 64-bit data type to save this number and later to shift it down with the floating point shifting bit which is 16. Yeah, so I make it to first not to be the macro and made it to be macro but rather functions. Yeah, rather as a functions. Yeah, so I make it to be a inline function with returning a integer 32 assign, assigned 32 bit integers. Yeah, so this is the manually multiplication of the fixed point arithmetics. So yeah, so in the first I will save the assigned bit of it, and later on using the unsigned representations, use the two unsigned 32-bit integer to represent a 64 yeah to represent a 64-bit integer in this cases. Yeah, and just manually done the multiplications by the manually code, and later to return the result based on the if the sign bit is one or if the sign bit is one or two. Yeah, if it one, just returning the negative of the result, and if it's zero, and it will return the original result that originated is unsigned. Yeah. Okay, so the next solve is yeah. is I changed the calculation logic in the floating point division. Yeah, in the original floating point division, that it will not only relies on the use of the multiply operand, it also will use the division operand in this case. So okay, so I change it like to do it manually by same as the multiplication. I also made it not to be the macro, but in the inline functions, and to calculate the division, include including the dividend, the divisor, quotient, the remainder during the for loops manually. Uh, these two codes are not seriously optimized. It just only be optimized with a straightforward cases such as in the division cases I used counting leading zeros, to determine the starting bit index, which is the starting bit index in the current division, to lower down the cost divi- of the possibly division in these cases. Yeah. And also the multiplication does is to check if the the abstract the abstract number of b is zero or not, to trigger if the multiplication is still be required to perform. Yeah. These two might have a better solutions uh, to achieve to solve this kind of problems, but it requires some of the future works to have a uh, more accurate simulations with these codes and some of the real calculations through the map through the steps calculation through the map through the math. Yeah. Okay, and so another case of my highlighted changes is to replace the modular operators. So the modular operators in this code in the original P3D implementations, in the original math operations in the P3D is in the sine functions and the sine cosine functions. Yeah. Uh, and the problem also is the same. Oh, and also the cosine functions of it, and also the cosine functions originally in B3D library will also use the modulo. Yeah, we'll also use the modulo that make it in order to calculate the calcu yeah, to calculate to reduce the integer 32T range before calling the sign. Yeah, just to lower down its angle. Yeah, so in oh first come with the sine and sine cosine. So for by not doing the fast modulo, with just straightforward doing the modulo, I change the code into the following code that performs the manually modulo. It requires the use of the fixed point multiplication and the fixed point division functions that I previously changed before. Yes, here and here. Yeah. So use these two functions in order to calculate the times of the current number with the division of the uh, 1 out of 2 pi. Yeah, with the multiplication with the input number with 1 out of 2 pi, and to to make the original number to subtract with the times of the with the with the uh, number of times in S3D floating point 2 pi. The constants. This is the 2 pi constants. I derived from the B3D in the math toolkit. but the magic is in the B3D assets, in the B3D library. Yeah, so this is what is modular is doing. So yeah, and for the cosine cases, I generally just change its uh, yeah, I generally just change its calculating logic. Like uh, and originally that will reduce the range of the it will reduce the range of itself before the number of it before the cosine value was uh, being passed into the sine functions. But in this case, since I cannot use the fast modulo to handle the overflow cases, uh, to handle the so in this case I don't have the modulo to handle the fast reduction process. So I just do the yes, I first considering the symmetric properties. So to take the abstract of the input angle and to first calculate the safe limit to check if this current is this current input value will be bigger than the safe limit, which is uh, the maximum number of the integer with minusing the half of the pi constant. Yeah, to check to calculate out the safe limit. For making the input number to check if it is larger than this kind of limit. If it is larger than this kind of limit, then I will. Uh, if it is larger than this limit, that means that this number, this input number, after adding the uh, half of the pi, will make the make the variable of it be over than the maximum of the integer, which will make it be a negative number in the floating with the floating point operations, which is not what we actually want in this cases. In this case, so I'll make it so if the number is over the limit, then I will subtract it with the 2 times of the pi, which is refers to this equation. So sine of x plus 2 of half of the pi will equals to of the sine of x plus half of the pi and minus the 2 pi. Yeah, so the sine symmetry, the symmetric of the sine function will be could be seen as a 2 pi. Yeah, and this is not symmetric. This is just uh it just subtract out a 360 degrees of from the original angles. Yeah, from the original angles. So I'll just minus the 2 of pi and add back the half of the pi and to pass the result value to the sine function, which means that the reduction of the angle will all be performed in the sine function or the sine cosine function, and not to make it be uh, processed in the cosine function locally. Okay. Okay. So after I do the both lots of changes, in theory that it was solve all the errors, right? But in reality, that I still have a single error if I compile with RB32I in this case, that it was still concerned with a single type of the error, which is the multiple single, the multiple symbol in the raster half function. So after some days of the broadcasting of the code, I couldn't find any line of the code that had a chance to occur this kind of situation. So including the use of the tools that I know in the GNU RISC 5 tool chains and XPack GNU RISC 5 and Beta GCC also, which is RISC-V non-L3 ELF minus R. So we could see that there is actually a simple constant while typing this kind of comment and to use the minus nm of the RISC-V toolchain, we could saw that there is a undefined symbol which is called MUSI3. But if you use the obj dump, then you couldn't even find any of this kind of the symbols or this kind of jumping functions, the jumping operations in the risk in the uh, in the packed object files after it is compiled. Uh, After it is compiled by the GNU Touching GCC. Yeah. So I so I finally finally I decided to make the compiler options to be arbitrary to IM with the CSR extensions considerations. And finally the combination success. And still in the object files in the obj dump, I couldn't even I still couldn't even find this kind of symbols or the like the multiplication uh RISC-V uh, instructions in this kind of in the compiled object files. So I don't know if it will have a chance to make the VGA validation progress to perform weirdly in the MyCPUs. So yeah, it is what it is. Yeah, and after I could successfully compile all the codes, compile the programs, then I do the test, and then I test if this compiled programs could be could success could successfully run in this case. So I so I test with the first with the early work and second with the alternative work. So first the early work is using the codes or the programs that I mentioned before is I use the S3D, the simple renderer, the simple 3D renderer that I derived from B3D for specifically for the VJ validation programs, and also the math operation header file, which is called H. Yeah, uh, you can see these changes in these comments. Yeah, so the S3D.c, S3D.h, math.h, and the VJ.c in here. The VJ.c is the main program of how or I expected the VGA comprehensive test would be taken. Yeah, the 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 comprehensive test programs that I expected to be. But for the current version of the VGA validation program, I didn't actually add like uh the symbols of the test cases, just as what UR.C does. I hadn't add this kind of symbols like the run test one, run test two, run test three. I didn't add this kind of things in here currently. Yeah, just to yeah. So for the early works of this VGA validation program, I just want to check if my renderer could uh, successfully render the object I wanted to render. So in this case is I make it to render a cube. Yeah, so this case is I make it to render the cube with the cube palette I took from the uh with the palette I took from the cube colors in the cube.c in the original example programs of the BQD library with doing the simple decomposition of the colors from the 32-bit into 8-bit. Yeah, from 32-bit color symbols into the 8-bit color symbols. Okay. And yeah, so this code is just try if the S3D, the simple renderers, actually can render this kind of a cube, and to check if this program can read the data from the B3D assets.h. After I link this program with the B3D assets.h header files. Yeah, and yeah, so the result of this work is as shown in the start of this section is it seems like it couldn't renders the image property that it only could just if you see the color palette that it only could just render the single page, and when I rotate it with about yeah, so for this code is I will rotate every is I use the uh, 12 angles, and I make it to rotate about a a whole 360 degrees with the division of the 12 angles with the division of the 12 angles to to make it will uh saves to make this program to save every uh every frame will actually rotates the cube in 30 degrees with the 30 degrees with the y-axis, which yeah, 30 degrees with the y-axis. So if uh, if it works well, then it expected that I will have had a rotated cube uh, that will rotate every 30 degrees in a in a uh, in a same FPS with what Nyancat the C will looks like. Yeah. With the same frame rate of Nyancat the C will looks like. Yeah. And so in this case, that it seems like it doesn't do the same at all. That it only could renders the one face of the cube, but not to make it to be like a rotated manner or something else. And this is the alternative work. So the next I do is I implement another work, which is another simple renderer. But in this simple render, I make it not to consider all of the I make it not to consider all of the cases while performing the clipping strategies. Yeah, so in the original code, of the B3D rendering, the B3D renderer, and also the S3D renderer that is derived from the B3D renderer, that is that the what is it called? Uh, the clipping strategies. So the clipping strategies will be in here. Okay, so that in this case that it will consider near distance, the near plane clipping, and also the far plane clipping here. But in the alternative work is the simple render.c. Yeah, here. It's a simple render.c that it wouldn't consider the where is it? Triangle is in it's in here. Yeah. So in this alternative work of the render that I not consider all of the clipping case in this in this program. Yeah. So the clipping case will be here. So yeah, I just typically make it clips the six planes, which represents the left, the right, the bottom, the top, the near, and the far, and then not other like the near and the far is I make it represents like a zero, and to W values. W values is the currently is a currently is the distance of the z value. Yeah, the distance of the vertex to the uh yeah, it is the value of the distance from the vertex to the 2D plane that it is intended to project. Yeah. So I took less considerations in some of the cases in the clipping and also make the camera not to set up everything. Yeah. So I uh delete the settings of the rows of the pitch and the yaw. In this case, others I believe remains the same. Yeah, others I believe remains the same. Oh, and also doesn't consider the FOV in this cases. Yeah, so you can see in the not here. Yeah, the initialize. I comment out the settings of the FOV. So this code won't consider uh the the different angle of the FOV and only consider that uh it is a 0 degree. Is 0 degree of the FOV. Okay, so this is the alternative work. And unfortunately, that my changing the alternative work uh, seems like it still serves the same with the rasterization result. Is that uh, it still will only uh, it still will only renders the single face or the single surface of the cube and not make it to be like a animated a rotated cube in this with this VGA displays, which is kind of unfortunate. Uh, and it still needs to the requirements of uh the future investigate investigations in it. And okay, so you might think that is uh if this is a chance that I run the same program the same object programs compiled by the makefile it well this won't be the case since the compiled object files in that is in this and the compiled object file in this program will always be the VG. I always name it as the vga.asm rather uh it is sourced by vga.c or it is sourced by the simple render.c. I'll make it compiled into vga.asm bin. So if you see that there's the same uh same same exec same executable ASM assembly model that is being assigned to the validator is it's kind of normal. Yeah, it is. It is suspected to be output like that. Yeah, and to make a check of the VGA, I changed the code with the check VGA makefile comment with uh making it read the ASM file rather than it is originally read the Nyancat as ASMB. Yeah, it originally, and I changed to read the VGA.ASMB while I was testing the simple render in this case. Okay, so this is the current progress of my final project in computer architecture. Well, so in conclusion, that is I spent some time for learning during this final project, the implementation of the final project. I spent some time to learning the chisel and to be familiar with my CPU, and most of the times in learning what is a 3D render or what the computer graphics techniques are looks like, and how to perform a triangle rasterization in a of a polygons or a 3D object or a 3D model. Yeah. Well, however, after those learnings, there are some techniques I'm still not familiar with, such as the clipping technique. So I don't know if it's right to in the software network to like make it less considering some cases while doing the clipping. And yeah, I'm not sure if it is right, but uh, it could compile it, and but it still but the result still serves the same. Yeah. So I don't know where's the problem of it, and still need further investigations in it. While I'm totally realized what this code or these techniques are doing and what the what the object file of it represents in here. Yeah. So yeah, this is the current progress on my final project and computer architecture. And thanks for listening.